All right, so yeah, we are having a test coming up, but I want you to make sure that you understand something about this whole process of hypothesis testing. Recall that I had said to you that there are a lot of people, only within the past 5 years maybe, who have said, don't do hypothesis testing. Only use confidence intervals. And the reason why is that confidence intervals give you more information. If I say, well, I checked with a bunch of Western students and I got a 30% that do the paddleboarding, and somebody says, well, is that accurate? Is that 30% the actual number? I can say, no, it's between 24 and 36. So then if I'm able to say that, that's better than just saying, is there evidence that there's a difference? Because clearly when I get to this point, I say there's not enough evidence, then I really don't get a lot of information from that. And even if I say there is evidence for a difference, that's not the same as saying this specific thing, this specific range of numbers is what's true about my population. So confidence intervals give us more information, and confidence intervals do not assume anything about a previous thing. Notice when we made this thing right here, when we made our picture, 30% is in the middle. I'm sorry, 35% is in the middle. So we're assuming that 35% is actually the correct value. And then you say, if it's correct 35, then 30 is less than that. But if I do confidence intervals, I don't have to mess with that. I'm just giving information based on my sample. So it's preferred in various situations to do that. But like I said, tradition for the past 100 years, people have been doing hypothesis testing. So it's probably not just going to go away. But it is something that people have trouble. They say it's not as good of an idea. So let's do a different kind of a thing now. So we're going to be looking at confidence interval. And well, we should take a look at our practice test just to make sure we're getting stuff right here. So if we go there, we're up to test number 5. And so we'll start with a confidence interval for the proportion. So let's say that I really want to know more about this paddleboarding thing. And so I decide I'm going to go out there and I'm going to survey 400 Western students. And I find that 130 say yes, that they have been paddleboarding. I want the 99% confidence interval for the proportion. So let's see if you can make that happen. All right, check with your neighbor, see what they got. What that means is I want you to stop working on the problem yourself. I want you to look at what your neighbor has and see if it's the same as what you have.
Yeah, that's what I
All right, Bill, you got something for me here?
I do not have.
Okay. Mattia, you got anything for me? Not yet? Okay. So, Caitlin, you got anything?
I have 0.2646.
Okay, so yeah, if we round those off, we could probably say 0.265 and 0.385. And that's where our population portion would be. Our p hat is 0.325. So then, yeah, at situations like this, generally speaking, right? And again, the whole issue of rounding, is it a big deal? It is a big deal while you're going through a problem. You don't want to round off too much at the beginning or at the initial stages or while you're doing the formula. At the end of the problem, then you're probably going to round off for a proportion like this to 3 decimal places. If you go to 4, well, that's probably okay. You don't need 10 decimal places, clearly. But if you go to 2, it might not be quite as accurate as you want, right? So it's just kind of a good idea to do these to 3 decimal places at the end of the problem. But you're not going to round off this 0.325 to 0.33 right away. That would not be a good idea, because then that's going to change everything about what's going on in the meantime. Mark?
Can we go through this one? Like,
Certainly.
step?
Yep.
I don't.
So we need a formula. P hat minus z of alpha over 2 times the square root of p hat q hat over n. That's on one side, and then on the other side we have a plus sign. P hat is 0.325. So this is 0.325, 0.675 over 400. And then we need the z. Alyssa, can you tell me how to get the z for this problem?
So, no.
Okay. Emily, can you tell me how to get z for this problem?
Don't you look at the confidence interval, which was 0.99, and try to find it on table E or closest to it?
Actually, no, that's not the best option. Best option is look at table F. When you look at table F, you say 99% confidence interval is clear over on the right-hand side, and you go all the way to the bottom, 2.576. That number goes right. All right, Maggie, does that make sense?
Yes.
Okay, Crystal.
Do you want us to use 0.2576 or like the chart you gave us is just rounded there to 2.58?
I want you to use table F.
Okay.
Okay. All right. So let's say that I'm looking at this and I say, oh, well, this is not really accurate. I want a much more accurate thing of this. So I want to find the sample size for 99% confidence interval accurate within 2%. And we're going to go with, I'm going to pick you a p hat here. I want you to use p hat equal to 0.5. Question me.
Okay, so if it's for the same size, then I should be using the mean before mean one?
No, this is for
Okay.
proportion. All right, maybe your neighbor has some ideas. You might want to check with them.
Well, I just. So that is the 2 point, the 99%. But he said he wanted us to go off this one, which is like the 3-digit one, so the 5/8.
All right, Hillary, you got a number for me there?
For
4,147 people. Now, you could say that. It'd also be correct if you said 4,148, because the textbook says you should always round that number up. And I say, if you're talking 4,147 people, it doesn't matter whether you have that 48 or 47. So it doesn't matter. But the number that you get would be 2.576 divided by 0.02 squared multiplied by 0.5. Does anybody recall from the textbook why I chose P equal 0.5? If you use P is equal to, or P hat, I'm sorry, if I use P hat is equal to 0.5, then it makes the interval the largest possible value. And so then that makes sure you have enough people to be that accurate. So if you don't know what P is originally, if you don't have a value of P hat to work with, then you just choose it to be 0.5 and it works. All right, and I'll give that to you on the test, so you don't have to worry about it. All right, so now we need confidence intervals for mean and standard deviation. That shouldn't take too long, so we might get out early. So we're no longer doing hypothesis testing. Is that already? Okay. So let's say again, what we have to be concerned about here is what does the data look like when we do this kind of problem. We are no longer asking yes or no questions. We're asking questions about how much. So if we say something like, how much calcium in the diet? And we have various people and we measure the amount of calcium in their diet, then we're going to come up with a mean and standard deviation question.
So when we first went through these, when we first learned them, we used like that little chart they gave us.
Right, we're not going to use that anymore. We're going to go with table F.
Okay, that was just kind of
Yeah.
easier. Okay.
So how much calcium do we want in our diet? I don't know, but let's just say that we have a mean of 60. We have a standard deviation of 25, and we have a sample of, what do I want? Let's just say 30. And so question would be, find a 90% confidence interval for the mean. Start there. Well, all right, so hopefully all the people around you have been very helpful to you and given you all kinds of good information here about how this works. So, Liz Tomitz, you got numbers that you like there?
I have no idea if I'm doing this right, I'll tell you what I came up with.
Okay.
So for the smaller side would be 52.245.
Nope, sorry. Katie Larkin, what do you got?
Can I tell you like the equation first? 'Cause I don't even know.
Sure.
Okay, so are we just using like the mean equation, so x minus t alpha over 2, yeah, over s, yeah, that thing. Okay.
Okay, so far so good. So
Okay.
this is 60, this is 25, this is square root of 30 down here. I need to know the t value that I'm going to put in here
Yeah.
for a 90% confidence interval. So, Katie, where are you going to look for that?
Are we supposed to work on table G?
No. This is the t distribution, so it's table F. Okay, if you go to the top, it says t distribution.
Oh, table F.
Yes.
Oh.
Okay. Alex, you got a number for the t value there?
No, I'm gonna pass, so you say that's fine.
Okay. Gabrielle, you have a number? Okay. Lissa? Oh. Right. Mara, you got a number?
Yes.
Okay. Anybody got a number here? Jessica? 1.699. How did you find that number?
Well, because don't you find that DF, which would be n minus 1?
Okay, DF is n minus 1, so we're on row 29.
And then you go over to 90%.
90% confidence interval, 1.699. We want. So Jessica, you got numbers then for me?
See, and that's what's weird, because the number she started out with, 52.25, I got that in my mind. I got 52.25. And
Yeah,
then
that's what I
thought. What? Oh, I put in the wrong number for standard deviation, that's why. Okay. All right, so let's go back to that. 52.25 on this side, and then and on the other side,
67.75.
yep, 67.75, right? That's great. All right, so, looks good to me. Now, so there's a problem though. All we are finding here is where the average is. So if we actually want to know, do these people get enough calcium in their diet? We don't. We can't tell. All we're saying is where the center of that distribution is. So if they're supposed to get like 40 or who knows what, we don't know because this is only telling us the center of the distribution. It's not telling us what to expect for the actual people. It's only telling us what to expect for the average, the center of the data. And even then, we thought it was 60, but it could be anywhere from 52 to 68. We don't know. Sometimes that's helpful and meaningful, but a lot of times it's not because it's not telling us what's actually happening. It's just telling us the average. So then we go even further beyond that and we say, all right, let's find the 95% confidence interval. For the standard deviation. I don't know about you, but I'm just kind of cold. All right, see what your neighbor's got going on there.
So this one's to the G.
Right.
No, I can't wait.
Wait, so 95 should be, but then you have to have 5%. No, 95, so it's 0.025. So that has to be 5% split in half. Gotcha, I was a little confused. You still did it right, just for different reasons.
That's great. That's like great.
No, that's fair.
All right, so it'd probably be good if we had the formula for this. Go ahead and put that up here. And as I recall, I'm pretty sure that I put this on the test. Did I put formulas on the practice test?
Yes.
Okay. So, yeah. So, chi-squared right, this is chi-squared of alpha over 2. Chi-squared left is chi-squared 1 minus alpha. So, where should we start here? Well, I suppose we should start by putting in numbers, right? So n minus 1 would be 29. That goes here. S squared, that would be 25 squared. I'm pretty sure I got it right this time. So that's in both of them here. But now I need chi-squared right and chi-squared left. Mara, do you have numbers for me? Chi-squared right, chi-squared left? Okay. Where did I put that? I don't know. Crystal Reed, can you tell me, you got numbers for chi-squared?
Right is 45.722,
Okay.
and the left is 16.045.
I've got 16.047. Okay.
Oh, yes.
So 16.047 on this side. What's the other one, I'm sorry?
45.722.
Okay. And so then we put those numbers in the appropriate places. And notice that degrees of freedom is 29, and that's in between. So this is on one side and this other side, 29. So then, hopefully, when we plug those in, we're going to get 19.9 and 33.6. Okay, Katie.
What are the steps to getting the left and right?
Great question.
I have no idea.
Okay, so when we say chi-squared right is chi-squared of alpha over 2. If we have 95%, then that means alpha is equal to 0.05. Alpha over 2 is 0.025. Okay? So then we're looking at the 025 column, and we go down to 29 degrees of freedom. So this is alpha over 2 is equal to 0.025, and degrees of freedom is equal to 29. So that's where the 45,722 comes from. Okay? And then the other one, we take 1 minus that number. So this would be 1 minus alpha over 2 is 0.975, and also degrees of freedom. So I think we've done a couple of examples where we had alpha was 0.05 because it was a 95% confidence interval. Certainly you need to understand if I were to change that, right? If I were to make that a 90%, alpha would be 0.1, alpha over 2 would be 0.05, and so on. All right, any other questions about confidence intervals for standard deviation? I think that's enough, so we'll pause it. So have a great 4th of July weekend. I will plan to see you next week on the 9th, where we'll have the next test.